Hi everyone, in this video we are going to go through the next topics, which is related to principle of moments. In many textbooks, this principle of moment also known as the Varignon's theorem. Okay, let's go ahead and start. Okay, so before I state what the Varignon's theorem is all about, let me start with the drawing. Okay, over here. Okay, let's say that we have a reference point O right there. Okay, and then with respect to that reference point, okay, in addition to that reference point, we have two forces right there. Okay, we have the force F1 and F2. Okay, so we have the force F1, let's say this is the F2, and we have the force F1 right there. Okay, so from what we have learned, right, in the module 2, that we can calculate the resultant force of F1 and F2 right there by kind of like using the help of this parallelogram sketch, right? So with that, right, so we are able to sketch the resultant force R right there, in which R is F1 plus F2 over there. Okay. In addition to that, right, so in addition to that, we also can define that there is a position factor, right, there is a position factors right there from point O, right, to, let's say that point right there, that's point B, right, so R or B is that position factors, right. So from what we have learned, okay, in the previous lectures, we know that moment about point O, this can be calculated as the cross product of R of B and R, right? This also can be calculated as, right, the cross product of, right, R of B, right, cross F1 plus R of B cross F2, right? So those two, okay, are basically the these two expressions right there are actually equals, right? And how can we prove that, right? So to prove it is actually a very easy to do. Okay, so if we substitute this R into right there, right, so we will have R O B cross of F1 plus F2, right? This will result in R O B cross F1 plus R O B cross F2. It's right there. Okay, and this is nothing but the same as the expression that we have written above. Okay, so in this case, okay, what we can say about the Varignon's theorem is that the moment of a force about a point is equal, okay, to the sum of moments of the component of that force about the same point, right? So the moment of a force, okay, about a point, in this case that force, let's say we call it R, right, is equal, right, to the sum of the moments of the components of the force. The components of the force right there is F1 and F2, and in here we sum up the moments contributed by that components of the force about the same point, which is in this case is the point O. Okay, so this is basically what we call as the Varignon's theorem. Okay, Varignon's theorem. Okay, we can see some of the more practical examples, okay, of the Varignon's theorem, especially when we are dealing with the moment of a force. When we try to calculate moment of force using the scalar formulations. Okay, in order to do that, I'm going to redraw another figures right here. Okay, let's say that I have the x and y axis right there. Okay, let's say that I have the x and y axis. Okay. So that is my x, that is my y. Okay, And then let's say that I have my resultant force, right? Right there, okay? Since we are working on the Cartesian coordinate systems right there, most of the times on the problems that we are going to solve, we can do this. We can decompose that force into its y component and its x components right there. Okay, it's x and the y components right there. Okay, and in this case, f is equal to fx plus fy right there. Okay. And in addition to that, we can also define a position vectors r, right? Okay, if we know that this r, right, has a component of rx and ry right there, or in other words, I can write my r as rxi plus ryj, right? We also know that fx right there is equal to fxi, right? And then the fy right there, that is equal to fyj, right? Is equal to fyj. And then from what we have learned before, right, from the Varignon's theorems, right, we can calculate the Varignon's theorem by, it's defined as this, right, r cross f, right, that is also equals to r cross fx plus r cross fy, okay? And if we only consider the magnitudes, okay, of these whole things, right, which is we just interested in the scalar formulations of this moment, right? So we will obtain, right, that this r cross f, the terms right there, okay, this is nothing but the rf times d based on what we have learned in the previous lecture. What does it mean on this diagram is that if I extend the lines of action of f right there, right, and then basically I can draw that is a perpendicular distance d right there between the line of action f to the reference point O right there, okay? And oftentimes finding this d is a little bit more challenging when we try to solve problems in the practical sense, okay? It's more challenging compared to what I'm going to show you next over here, okay? So calculating this cross product right here, and if we just concentrate on the magnitude of it, right, we are going to obtain negative fx times ry, okay? Note that it's basically you take that force that's going to the right, and then you have that perpendicular distance right there, right, which is ry, and then that's going to give you a clockwise moment, right? And we know that based on scalar formation, that has a negative component, right? It's have a negative sign, right? And then plus the result of this cross product will give you, the magnitude of those cross products right there will give you fy times rx, right? Which is just the scalar forms right there, okay? Because we just consider magnitudes, and note that is basically you take that fy right there, and then with respect to the point O, it's going to make a counterclockwise rotations, right? That's why it has a positive sign right there. Okay, so in here, okay, as I said earlier, it is when we solve problems, it is often more difficult to figure out what is that perpendicular distance d with respect to the force F, okay? Oftentimes, okay, it is much easier. The problem's already given us the Ry and the Rx informations. So the only thing that we need to do is to decompose that force into its X and the Y component, which is oftentimes it is much easier to do compared to calculating the D, okay? So that's pretty much what I would like to say about these principal moments. Later on, you guys you'll be able to do some more exercise in order to enhance your understanding on these concepts right here. Okay, thank you for listening, and as always, if you have any questions, please let me know.